Hello, welcome to Earth Metrics. My name is Faiza Msemo, a GIS and Remote Sensing Specialist. In today's lesson, we're going to learn about two very important types of spatial data using GIS, Vector and Raster Data. If you're learning GIS, this is one of the most important concepts to understand because almost every map, satellite imagery, and geospatial analysis uses either vector data, raster data, or both. So by the end of this lesson, you understand what vector and raster data are, where they are used, and how they work together in real-world geospatial analysis. Before we discuss vector and raster data, let us first understand spatial data. Spatial data is any type of data that is connected to location on the Earth's surface. For example, roads, rivers, buildings, farms, forests, schools, water bodies, and district boundaries can all be represented as spatial data. In GIS, spatial data help us answer location-based questions such as where something is located, how far it is from another feature, what surrounds it, and how it changes over space. This information is mainly stored and analyzed using two major data models, vector data and raster data. What is vector data? Vector data represent real-world features using geometry. There are three main forms of vector data: points, lines, and polygon. A point represents an exact location, for example, a water well, a school, a tree, a house, or a weather station can be shown as a point on a map. A line represents features that have length. Roads, rivers, pipelines, power lines, and footpaths are commonly examples of line features. A polygon represents an area. Farms, lakes, forests, buildings, land parcels, wards, districts, and country boundaries can all be represented as polygons. Vector data is very useful when we want to map features that have clear shapes, locations, and boundaries. Raster data. What is raster data? Raster data is different from vector data. Instead of using points, lines, and polygon, raster data is made up of a small square called pixel. Each pixel stores a value. That value can represent different information such as elevation, rainfall, temperature, soil moisture, or satellite image reflectors. For example, in a satellite image, each pixel stores information about the surface area it represents. One pixel may represent vegetation, another may represent water, and another may represent bare soil or buildings. Raster data is commonly used in satellite images, drone images, digital elevation models, rainfall maps, temperature maps, and climate datasets. This makes raster data very important in remote sensing and environmental analysis. So, let us compare vector and raster data. Vector data uses points, lines, and polygon. It is the best for features with clear shapes and boundaries, such as roads, rivers, buildings, land parcels, and administrative boundaries. Raster data uses pixels or grid cells. It is best for continuous surface and image-based information, such as elevation, rainfall, temperature, vegetation cover, land surface changes, and satellite imagery. For example, if we want to map the location of road, vector data is usually the best option. But if we want to analyze rainfall distribution, vegetation health, or elevation, raster data is usually more suitable. So the choice between vector data and raster data depends on the type of information we want to represent and the type of analysis we want to perform. How vector and raster data work together in a real GIS project. In real GIS project, vector and raster data are often used together. For example, in a site suitability analysis, we may use raster layers such as elevation, slopes, rainfall, vegetation index, and land cover. At the same time, we may also use vector layers such as roads, river settlements, administrative boundaries, and land parcels. By combining these layers, GIS allows us to understand spatial patterns more clearly and make better decisions. For example, in agriculture, we can combine rainfall maps, soil data, farm boundaries, and road networks to identify suitable farming areas. In flood risk mapping, we can combine elevation data, river networks, land use, settlements, and infrastructure to identify areas that may be exposed to flooding. This is the real power of GIS, combining different layers of spatial information to solve real-world problems. So, to summarize, vector and raster data are the two main types of spatial data used in GIS. Vector data represent features using points, lines, and polygons. Raster data represent information using pixel or grid cells. Vector data is strong for mapping clear features such as roads, rivers, building parcels, and boundaries. Raster data is strong for satellite imagery, elevation, rainfall, temperature, vegetation analysis, and other continuous surface information. Together, vector and raster data form the foundation of GIS analysis, remote sensing, mapping, and geospatial decision making. Thank you for watching Earth Matrix, and please don't forget to like and subscribe and follow for more beginner-friendly lessons in GIS, remote sensing, survey, and geospatial analysis. See you on the next lesson.